The last part of chapter 6 is really just taking what we've already done with this idea of separating and integrating and looking at either more complicated ones or more given information, more required steps to go through. So it kind of recaps what you've already done and just takes it maybe to another step or so. So I'm going to do 2 in this video and then I'll do a few more in another video. So the way that we present it often on the AP test is they'll be presented as a differential equation. They will give you initial information to find your C value. So that's what this 1, 2 would be. And then sometimes they'll ask you to go even a step further and ask you to plug in another x value into that particular solution. So I found 2 that are examples of that I want to put in this video. So step 1 is to separate. So separating in this way, I'm going to divide the y squared to the left side. So I'm going to get dy over y squared. And then I'm going to move the dx to the right side. So I have dy over y squared equals dx over x cubed. Both of these are just power rules. I know a lot of the problems end up having natural logs or e's in them, but this one is not. It's just a power rule. So power 1 greater divided by that power. Power 1 greater divided by that power. So cleaning it up a little bit, I get negative 1 over y equals negative 1 over 2x squared plus c. Find your C value. So plug in your initial condition, which is 1, 2. So we get negative 1 over 2 equals negative 1 over 2 plus C. You actually get C to be 0 in this one. So your equation is negative 1 over y equals negative 1 over 2x squared. Now that it's a proportion, meaning you just have a single fraction on the left side and a single fraction on the right side, it is perfectly acceptable to flip each side. And you can also get rid of the negatives and write your particular solution a little cleaner. You can write it as y equals 2x squared. If you have a C value that is not 0, you can't just do that. You can't take a fraction and just flip. What I mean by that is we can't say that 5 equals 2 plus 3. That does not mean that you can say that 1/5 equals 1/2 plus 1/3. Math doesn't work that way. But once you have a proportion, it is perfectly legal to flip that. And then finally, to finish this, you're going to plug in your last bit of information, which is x equals 3. So we get y equals 2 times 3 squared. 3 squared is 9 times 2. Our final answer would be 18. And these are most often multiple choice, which is what I'm going to show you on the next slide. So this next one, same idea. It gives you a differential equation. I pulled this one straight from the AP Classroom site. They give you an initial condition when y is negative 1, x is 1, and then they ask you to figure out what y equals whenever x is 2. So the same type of setup. So I have dy over dx equals 2y squared. So this 2y squared needs to move to the other side. Or you could actually just move the y squared. You could leave the 2. I might do that. That might be a little easier. Sometimes I don't like to move constants from where they are because they can often make things a little more complicated. You can move the 2 to the other side if you want. You just have to pull it out front. So when I integrate, this is a y to the negative 2, so we get another y to the negative 1 over negative 1. And this side is just going to be 2x plus c. So we get negative 1 over y equals 2x plus c. Plug in your initial condition, which is 1, negative 1. So when I put negative 1 in for y, I get 1 equals 2 plus c. Subtract 2 from both sides. I get c to be negative 1. So negative 1 over y equals 2x minus 1. Rather than trying to clean it up and get y by itself, I'm just going to immediately plug in the value that's given for x and then solve for y. So I get negative 1 over y equals 2 times 2 is 4. 4 minus 1 is 3. So now let's solve for y. We're going to cross multiply. So 3y equals negative 1. So y equals negative 1/3, which is b. These problems are very algebraic. The calculus really is at the very beginning whenever you're integrating. After that, it becomes entirely an algebra problem where you have to use your algebra skills to be able to solve for x or y and plug in different values.